So for our mechanism, I chose to do the acid-catalyzed hydration of an alkene. I'm doing the Markovnikov addition, so my reagent is hydronium, or H3O+. To begin this mechanism, step 1 is a proton transfer step. So the double bond of my substrate is going to reach out and grab a hydrogen from the hydronium. That hydrogen is then going to be added onto the less substituted side of that alkene, while the protons from that leaving group, semi-leaving group hydrogen on the hydronium are going to be transferred to the oxygen. This former hydronium ion is then going to form neutral water, and I'm going to have my new substrate with my hydrogen added onto the less substituted side. Now, since the double bond has broken, there's going to be a tertiary carbocation on my substrate. This is the most stable form of this carbocation, so it's going to stay exactly where it is. There's not going to be any rearrangements. Now, since in the first step, I formed neutral water, this is going to begin the nucleophile attack step. So this neutral water is going to act as a nucleophile. One of the lone pairs from the oxygen is going to attack the tertiary carbocation. That's going to form a bond there, and so the water is going to add on to this most stable position and the most substituted position. After that's the deprotonation step. So a second copy of my water is going to come in. It is going to act as a base, and these lone pairs from my second copy of water are going to attack one of the hydrogens off of a now positive water molecule, and this positive water molecule is on my former carbocation, because water makes 2 bonds and now it has 3. So anyways, so once this second copy of water attacks this hydrogen, the electrons from that hydrogen are going to move on to the oxygen on the water. This oxygen on the water is then going to form a tertiary alcohol group, and this former second copy of water is now going to be a hydronium ion.